Warning, due to a 1 minute recording time limit, you may hear fast talking. Thank you. Hello guys, my name is Joe, and we're about to complete a task involving operation with scientific notation. My project is gonna be a big one, I can tell you that. So, our task involves ants versus humans. Everything will be explained on the video. So what must be done in my task? Well, they want me to compare the total mass of all living ants in the world compared to the total mass of all living humans in the world. First, write all numbers available in the task. First, mass numbers. So, we got the mass for one eeny weeny ant, which is 0.004 grams. Here, 0.04 grams. Next, the human sits around 65 kilograms. 65 kilograms, or you can turn it into grams, and it will be 65,000 grams. Here we go. Now we all have those mass numbers, all under one same unit, grams. Got the mass numbers? Now for the population numbers. And kindly, the test has already given us those available numbers. First, the ants. Always with them ants. Well, the ants are at the amount of 10,000 trillion. 10,000 trillion ants. That is a whole lot of ants. For humans, we are only 6.84. Here, 6.84 billion to be exact. 6.84 billion humans. So, we got the ants population and the humans population. Now onto our task. First up, we have to turn all of the numbers into scientific notation form. First, the ants. We got the ant population, 10,000 trillion. We are going to turn that into scientific notation form, which is 10 to the power of 4 times 10 to the power of 12, because trillion has 12 zeros. Now that we have them in scientific notation, just add them all together, and we have 10 to the power of 16. That is going to be our final answer for the ant population in scientific notation form. Here, 10 to the power of 16. Final answer. Now we have to find the mass of one ant. The mass of one ant has already been stated to be 0.004 grams. Turn that into scientific notation, you get this. 4 is already from 1 to 10. So take that 4, then multiply it by 10. Now see all these zeros? There are 3 zeros going the negative direction. That means taking all those zeros and turning them into negative 3. See? 3 zeros, negative direction. So, your final answer should be 4 times 10 to the power of negative 3. I repeat, your final answer should be 4 times 10 to the power of negative 3. Now, your final answer to resolve the ants is to multiply those numbers. So, do it like this. Take 4 times 10 to the power of negative 3, multiply by 10 to the power of 16, as shown on how to find the population of the ants. You get this number. See those 10s? Just take negative 3 plus 16, you get 10 to the power of 13. 4 doesn't have any effect, just fill that 4 in. So, your final answer should be this. 4 times 10 to the power of 13. I repeat to myself. 4 times 10 to the power of 13 must be your final answer. Note that all 3 procedures use the product rule to get their answers. I repeat, all 3 procedures were using the product rule to complete their answer. That is going to be your final answer to resolve on what type of rule they were using to solve the ant problem. You might see this in the humans one too. Now, on to the human's turn. So, we already got the answer for the human's average mass. The human's mass is said to be 65 kilograms, or turn that into scientific notation, which is 6.5 times the 10 to the power of 1. But wait, this is supposed to be kilograms. This is supposed to be grams. So we already got that answer, 65,000 grams. Turn that into scientific notation. We already got the 65 part, but what about this part? Easy, just turn that into 10 to the power of 3. See that? 3 zeros all pointing to the positive direction. So, your final answer should be 6.5, wait on a second, 6.5 times 10 to the power of 1 times 10 to the power of 3, which resolves to be 10 to the power of 4. And what about the human population? We haven't done that yet. Well, it's about to be done right now. The human population is already been stated to be 6.84 billion humans. 6.84 billion humans. That's a whole lot of humans. So, turn that into scientific notation form. Since 6 is already from the line of 1 to 10, we can already set that out and just take 6.84, and since we have the billions here, billions have 9 zeros, 9 O's, so we have to multiply it by 10 to the power of 9. That is going to be your final answer to the human's population in scientific notation form. I repeat, your answer for the human's population should be 6.84 times 10 to the power of 9. Final answer. Now, time to resolve the human stuff. So, we already got their population to be 6.84 times 10 to the power of 9, and then we just have to multiply that by 6.5 times 10 to the power of 14. Nope, sorry, I made that mistaken. It was supposed to be 10 to the power of 4. Minus that, please. Thank you very much. So, we just had to multiply them all together, and after some careful extraction, your answer for 6.84 multiplied by 6.5, you get 4.446. And for the scientific notation of 10, you just have to take 10 to the power of 9 plus 4, you get 10 to the power of 13. This is going to be your final answer for the humans, all entirely. I repeat, your final answer should be 4.446 times 10 to the power of 13. Final answer. These three procedures also use the product rule to get their final answer. I repeat, the product rule is the only rule used in this to find their final answers for the humans and for the ants. The product. Say that with me. Product. Now, time to wrap up the task. So, ants is 4 times 10 to the power of 13. Humans, let's just say that humans are 4.446 times 10 to the power of 13. So, we can conclude the total mass of all living ants in the world is indefinitely smaller than the total mass of all living humans in the world. That concludes our task. Thank you for listening. Hope you've understand during this task.